Oh, you started.
Great. Okay, great. All right. Well, welcome everybody. We'll go ahead and get started. I can imagine there'll be some folks coming in from the auditorium, but it's a great pleasure to get to introduce a friend, Mike Dillinger, and someone whom I respect very much in this field and learn from continually. So please join me in welcoming Mike.
So, good morning. So one of the things I want to talk about is working on this field that's really quite fragmented. Work in a field that's really quite fragmented. Can you hear me okay now? Yep. Cool. Great. And one of the things that happens is when we talk to clients, we fail to realize that our clients really don't need knowledge graphs or label property graphs or any of these other products that we're so interested in building. Okay? They need insights at scale right now. This is what they come from. This is what they come to us for. Okay? And insights come from combining data and knowledge. So this is why we're here. And how can we this is the question of the day. How can we get AIs to do this reliably? But one thing we have to do is choose carefully. So what do you see here? So I see trees on one side and trees on the other side. And this is important because some approaches to AI can't see the forest for the trees. Okay, that's the only joke I'll try to fly with today. Okay? Some AIs model what people say about the world, and others model the world itself. Some AIs model popular beliefs. Others model expert knowledge. And we can go on like this. Some have models based on opinions and frequencies and context, and others have models based on evidence and coherence and concepts. Some focus on words, like elephants. This kind of elephant has a height of 24 pixels. That kind of elephant has a height of 10 feet. Some focus on phrasing. This is one of my favorite examples. When I was at eBay some years ago, I found 20,000 plus variations on a single assertion. Can I pay with PayPal? Can I pay with PayPal? Or do you accept PayPal? 20,000 distinct variations. Some approaches focus on the phrasing, and others focus on the fact it's only one fact. Okay? Again, some approaches store random opinions and try to sort through them as harvested words and sentences, and others store reliable knowledge as curated concepts and facts. You seeing where I'm going with this? We have a couple of opposing approaches. Cool. So for well-phrased insights, that's what everyone's looking for, we build LLMs. But for well-reasoned insights, we build structured knowledge. So the choice should be really clear, right? Which one are you going to favor? This side or that side? Anyone? Yeah? Right or left? Right or left? Cool. Okay. So you fell into it. But now I want you to think again, right? The choice is actually between using both of them or a slow, painful death, like drowning in data. Okay? We really need both. We absolutely need both. Okay? That's the key point that I want to make here. And this is what makes knowledge graphs so important, is because we need both of them. So insights come from combining data and knowledge. We know this. LLMs work really, really very well with text data. Okay? I call them the ultimate API for humans. And knowledge graphs work very well for knowledge. So they're the ultimate enabler for reasoning. This is why I'm saying we need both. Okay? So they're complementary strengths and not competing options, no matter what other people want to tell you. Okay? So, how? How can we move ahead with both of them? One way of looking at it is saying we need to manufacture next generation knowledge. What we have now isn't sufficient. And that's what I want to talk about for a moment. So I see lots of people saying, we built huge knowledge graphs and they're really impressive and they're wonderful. But that's now, and their knowledge graphs have labels. When you open up the nodes in the knowledge graph, what do you see? Nothing. They're just labels. Okay? Next generation knowledge graphs are going to have all sorts of things inside each of the nodes. Rich nodes. I call them rich knowledge graphs because of that. We have a lot of work going on that. This is one of the reasons why the semantic, what we've inherited from the semantic web and what people are doing with ontologies are so important, because they help us fill in the nodes and make them more expressive, more informative. Okay? So I wanted to give you an example of when I was building the knowledge graphs at LinkedIn, what we did to make more expressive nodes in the knowledge graph. So when I got there, we only had 150 million distinct job titles. Okay? And the first thing we did, of course, to pare it down to size, was impose a frequency threshold and say, okay, the only ones that have business relevance, possible business relevance, are the top 50K, most frequent ones. Okay? They're still raw strings. The first thing we did then, in our quest to move on to next generation knowledge, was transform the raw strings into what I call concept labels. We did what Paco likes to talk about, entity resolution. So which of them are synonyms? Okay? So this step with entity resolution, we did some terminology work to cut things down to size. Notice it's a 10x reduction. Okay? So we covered the same strings, but from here forward, we only have 5 to work with, 5,000 to work with. Okay? That's part of the importance of entity resolution. And what did we do there? We started featurizing them, unpacking the concepts, right? So that not only did we know this is a unified thing that has several synonyms, we unpacked it and said, oh, cool. So one part of it is the role, another part is the specialty, another part is rank or seniority. So we decomposed or unpacked the concept like this to make it richer. Okay, and that yielded enriched concepts. So not only have we identified the concepts and labeled them, but now we're enriching them. We enrich them. Okay? We added facts about each of the concepts. That's what I mean. But we didn't stop there. So we built taxonomies for the values of each of those features. Okay? To enrich it. So even more enriched concepts. Okay? We added facts about the features, not only about the concepts themselves. And we continued to do that. So we built knowledge graphs, not only lists or taxonomies of features, but interrelated lists, knowledge graphs for the features there. Okay? And what this gave us was an increasingly expressive concept for each of the titles that we so much needed. Okay? And this was basically more kinds of facts about each concept. What did this deliver? A wide range of insights, because we use the same descriptive or meta language to describe other entities that were relevant in the economic graph at LinkedIn. Okay? And this gave us more and more ways to show how titles are related to each other, to skills, to tools, to industries, to everything else. Okay, so this is progressively more expressive nodes. So I came up with a checklist here to talk about. How can you do this? Think about the checklist this way. Are you focusing only on the most important entities? If we tried to do this for 150 million, we wouldn't accomplish anything, right? If we identified the most important ones. Which kinds of nodes were you looking at? You notice these were all job titles in this example. Right? We have to focus to be able to make progress. And then we went on and we tracked our progress by checking how many attributes or features do we have for each entity? How many synonyms do we have for each entity? That gave us robustness for search. Okay? And then we started branching out and say, okay, well, how many kinds of relations do we have to make it even more expressive? This is for nodes. Something similar goes on for relations. So in a lot of the knowledge graphs that I call, is that here? Not yet. Okay. That we see out there that are just string for node, string for label, for relations, string for node. Okay. There's really not a lot to it. What I'm saying here is next generation will require us to have all of our relations informative, not just labeled. Okay, this is where we're going. And when I talk about expressivity here, I'm basically talking about coverage of different types of relations. Okay, we have classes of relations, we have types, we have relations between relations. We can do things like that. So just to track, so I like to use some basic categories here that are based on the signature of the relation. Okay, so you have things like relations between one category and another category, or between an instance and a category. These are all familiar classes of relations, but how many can you cover at a given step in your development? Okay, and this is a concrete way for measuring expressivity of your relations. Okay, and that's part and parcel of this checklist of relations too. How expressive are they? Are you focusing on the most important ones? Maybe you only need taxonomic relations for a given use case. Most often you don't. How many kinds of attributes, relations do you have? How many attributes for each relation? We can go on like this, but you have a quick and dirty checklist here. So you can track progress in expressivity. And next generation knowledge has more expressive facts. So once we have, I've talked to people here who have a problem where they have a knowledge graph, but the labels, the relations are just generic, related to, or similar to kinds of things. They're not informative enough. They're rather like these. Okay? I call these counterfeit knowledge graphs. And Kurt, who can come today, calls them naive knowledge graphs. Sure, they have graph structure, but the knowledge part is kind of questionable because what we have, in fact, are strings and not concepts. Okay? So if we want to talk about more expressive facts, we can apply different types of relation, facts that I talked about a second ago, and look at things like, okay, well, LLMs have really very few kinds of relations, basically related to, something generic like that. But when you go into taxonomies, there are more systematic relations, right? Relations between categories, category and subcategory, relations between instances and categories. Is this useful? Of course, it's essential. Is it complete? Not in the slightest, okay? It's less expressive than other forms that we know about. So I say this is low expressivity, but absolutely essential, right? Because we can take these and build on them and build things like ontologies, which have a much wider range of relations that they can cover. They're much more expressive. They're not an alternative. Okay? I've talked to so many people who say, no, I don't want to do taxonomies, I have to do ontologies, right? And vice versa. So this is good. Ontologies give us more expressivity, important kinds of expressivity, okay? But again, they're the basis, the foundations for building something even more expressive, right? Which are what I call rich knowledge graphs, the ones that have concepts and not just labels. Okay? So taxonomies and ontologies are essential components of rich knowledge graphs. Okay? Not alternatives. Are we done? We're not. There are a lot more things we could do. We can build on the knowledge graphs and, move on. So these are already quite expressive because they're not built on such restrictive constraints. Okay? We can include many other things. And we can build on those to build things like hypergraphs. Okay? Which encompass a much wider range of relations and types of relations. Okay? So what we see in the field is we're progressing towards ever richer, ever more expressive forms of structured knowledge. Okay? So this one here is really quite expressive. Okay? But it's something that's only starting to show up. So that gives me my facts checklist. For your use case, for your application, what kinds of facts do you need? If there's a mismatch here, then you're in trouble. Okay? Because you're using an underpowered form of knowledge representation for a use case that requires something more powerful. Okay? And we're seeing conversations about this. If you saw Aura's presentation yesterday about RDF 1.2, well, cool, we're talking about relations between relations, relations between facts, reification, these kinds of things to help us move in this direction of greater expressivity. Okay? So we talked about next generation knowledge is more expressive, but it also has to be interoperable. Okay, so knowledge today is this really confusing landscape. If you ask any clients, if you talk to clients ever, then it's like, what am I supposed to do? There's so many things and how am I going to choose? Okay? And to a great extent, we have independent efforts, which is slowing our progress down. And many people are talking about them as separate products. So this creates confusion for stakeholders and they're more reluctant to move in this direction. So for next generation knowledge, we have to package it and say, we're in the structured knowledge business and it encompasses all of this stuff and you don't have to worry about the differences. Okay, that's our job. Okay, and then we help each other. So this is very important. It's all one product. Reliable, structured knowledge. These are durable assets, right, that only appreciate in value, and they're exactly what we need to turn data into insights. Okay? And this is what our clients need. What do we got? Yes. More is coming. Next generation knowledge is more powerful than what we have today. A lot of people are focusing on static triples. Okay? It's already enough of a challenge to build those, but there are many more things that are coming. Okay? So again, Aura talks about reification and how RDF is meeting the need better to do reification. So we have basically this innovation that we can use whole tuples as nodes and relate them. Cool. I've heard mention here, and it's really interesting, of people beginning to use APIs, and so nodes, rather than static repositories of facts, are becoming dynamic and active. So the node contains a procedure or a piece of code or a query or an API call. Okay, these are much more powerful nodes than what we usually do. Okay, and these I'm calling active nodes at the moment. So why not take the next step and say, put logic in the node for self-validation? Okay, and then we can start automating the process of making the graph grow organically in a verifiable way. So relations too are evolving and becoming more expressive and more powerful. People are starting to include temporal relations. Okay, so we can model dynamic systems. Standard knowledge graphs, the ones that we've been doing for the longest time, don't have that information. Okay, and I saw here even mention of hypergraph nodes. More complex relations, not just triples, tuples. Things like my favorite example is Steve sold his motorcycle to Tom for $5,000 on Friday. You can't put that into triples. Okay, so this is one of the reasons why we need hypergraphs. Okay, and this is what's coming. I already see people mentioning it here at this conference, both of them. Okay, and more powerful tools are coming too. Okay, I think we need to do things like graph crawlers or spiders, right? We have networks, right? We've developed crawlers before for search, for other applications. Why don't we let them loose on our knowledge graphs and say each time you get a node, what are the connections to the next nodes? Is the node complete? Is the node valid? Okay, is it grounded? So these are coming. I also heard mention this week of continuous truth values. So knowledge graphs are not discrete. They don't have to be discrete. A lot of times we're assuming they should be discrete, but they don't have to be. So if you remember Apple's, the knowledge graph that powers Siri, it's called the Saga system. Okay, the very first thing that they did was turn the triples into quads and have a confidence score. This is continuous truth values. Okay? No one said that knowledge graphs have to be discrete. I keep hearing this, but I don't think it's true. Okay, and one thing that I'm particularly interested in here is we're starting to see systems for automatically building graphs. Okay, not only label to label to label graphs, but graphs with concepts. And this is going to be essential for us to be able to scale and validate at scale. Okay, what else do we got here? So what I'm asking you to do is go out there, use the skills that you have, they're priceless, and turn big data into even bigger insights. Okay, that's the point here. We have a lot more to do. Everybody has to pitch in, but pitch into a joint enterprise and not each one in his own corner. Okay, when you get into trouble, just call us. We're Hypergraf consulting group. The clients come to us seeking to create order from chaos. Nobody laughed. Okay, lots of chaos. Chaos that they don't even know that they have. A lot of times they come to us saying, okay, this is what we're doing. Do you see any gaps? Do you see any opportunity for us? This is fun stuff. And we're doing a lot of what I call matchmaking. So matchmaking is something that's really a core function of almost any company. Matching candidates with jobs, matching content with consumers, queries with products. Okay, so search is in there. And this is something I hear a lot about from our clients. Okay, thanks a lot for your attention. I wanted to leave some time for questions, and let's go.
So I have a question. I found it very interesting how you sifted down to all the LinkedIn titles, and I'm wondering, as you did that exercise, were you noticing structure of how titles report to other titles within an organization? Were you actually discerning like management and org structures within a given?
At the time, we weren't, right? Because that didn't seem like we weren't, but then we started a project for career development steps, okay? And that was much easier to do when we had the richer information about titles than just the string. Mm-hmm. Sure, hi.
Hi. I see a lot of your clients already have, in some cases, historic information organization practices such as eBay.
Yep.
When you work with those clients who've already made a lot of investment, who have really storied expertise in the space, and you find out that there is unacknowledged chaos, how do you approach that from an interpersonal perspective, both with business leaders and issues?
We'll always start from what's bugging you? What are the problems? Where are your pain points? And then we go backtrack from there and say, okay, so your queries aren't matching. You have very many low or no results, for example. This is something we did a lot at eBay. This is where I learned working with the search group. And we diagnosed that to say, okay, so this is one of the things that you're doing that you haven't done yet. And in a lot of cases, people complain about search, but they don't have the search logs around to look at. So this has become a problem with a couple of clients where it's like, okay, first thing I want to see are your search logs. Search logs? Where do we get those? Okay. What else? Then go through and see, in some cases, okay, let me see the taxonomies you use, or the knowledge graphs you use. And I was talking to someone here who was saying, oh, we have a really big knowledge graph, but it doesn't seem like it's helping. So as you dig, you see, okay, well, what kind of relations are you using? And it turns out that they had lots of really weak, uninformative relations at a huge scale. This is just informative enough. So this is troubleshooting.
So most of your clients are open to change rather than looking for someone.
I wouldn't go that far, but some of them, no, most of them want to know what's going on.
This is group therapy. Do you want to
Thank
tell
you.
us about your
Yeah.
experience?
I will at 11:30. Thank you.
Are you going to be talking about that?
Indeed, I will.
Yes, wonderful. Okay. Any other questions? No? Yes?
Hey, Mike,
Oh, sorry.
back to the job titles example that you started off with.
Yep.
Like the ultimate expert in what their job title is or what their role is the actual user. Do you ever like circle back at the end? Like, do they see how the words that they're using relate to the broader model? Because maybe they're not getting the right.
I wish.
Yeah.
This is something we lobbied for and couldn't get to fly.
Yep.
Okay, so I don't know if you know, but on LinkedIn, we have 2 layers. You have your data on your profile, and that's sacrosanct. We're not allowed to touch it. But we have mirror that, and we have a standardized version of it, which is our best guess of what it was you meant. Okay, there are some really wild titles out there. Okay.
Yeah.
Right, so we have to resolve things like code ninja actually means software engineer. Okay, lots of those. No, Java master, Java artist. I have a list of those. So there's some really hilarious ones. But if you do string matching,
Some of the code ninjas are changing their profile.
there you go. By string matching, then you're dead, essentially. Right, so we have to do the entity resolution.
Yeah.
And a lot of times it's not easy. But feedback would be great to be able to do that. And there was a huge emphasis on privacy of users, individual users' data. So we really had to step away from that at the time. Yes, sir.
I was hoping, can you talk about how do you, when you went from the reduced job title list to the entity resolution part,
Yep.
like at that scale, the thousands of job descriptions, can you talk a little bit about how you like did the quality control, that you actually did it right?
Wait, let me go back to this so you can. So this is, which step are you talking about? This one here?
Yes,
Or further on?
that one, the first one.
Entity resolution?
That you actually got it right, because it's like you said, it's like a kind of like all over the place. The
Yep.
job titles, like how do you do quality control there?
Manually,
Okay.
right? So I had a very, very good team there. And we'd spent a lot of time aligning on criteria and methods to be able to do this. Dying to be able to automate all of those guidelines that we came up with, but at the time it wasn't possible.
Hard.
Did you manage to do anything with that?
Oh, yes, you automated the heck out of it.
Okay. So Sophos inherited my team there and pushed them ahead in automation quite a bit. Okay, maybe you should give a presentation next time, or we'll do one together next time. Okay, so I'll do the before part and you can do the after part. Yes, sir.
So you mentioned about hypergraph tuples, right?
Yep.
So what percentage of your customers or in the industry do you see that already thinking about it or have implemented it? That's my first question.
Yep.
Second question is about how practical it is with today's tooling or the databases that we have to actually implement them.
So that's a really great question. You really don't want to lock yourself into a triple store that can't be expanded. Okay, because we already know that you're going to need more than raw triples. Okay, so that's one part of it. How many people are doing hypergraphs? It depends. So in manufacturing, all of this stuff about digital twins is based on processes that require hypergraphs. Okay, there are some people in the room who've been doing hypergraphs for a long time. Okay, if you want to know about them, you talk to Dave over there. It depends a lot. Okay, so for example, at LinkedIn, I wasn't modeling processes, so we really didn't need hypergraphs. This is why I was saying we have these degrees of expressivity, right? But they have to fit your use case. Okay, if you're modeling manufacturing processes with a taxonomy, you're dead. It's not going to fly. Is it? Yes.
So how do you build the graph or something where a single fact is significant. So for instance, medical research, so they can looking at genes expressing proteins and proteins interacting with each other. There might only be one paper about one gene, but that could be connected to more to other stuff. But you might eliminate it in that first step, or maybe the second step.
That's right. We would. We had a very, very, very small team. So we had to make a business decision. What's business relevant? What could possibly be relevant for the business? So we had to do some culling. Okay, are there a lot of other things that might become important? In fact, they were. So after this, the project I'm talking about here, we went in and did something similar for domains. Okay, so if we rank these based on global frequency, then a lot of things are just going to disappear. Later on, we did a project on nursing, for example, and none of the nursing titles at all showed up at the top here. But then we did the frequencies by domain and said in this domain, let's extract the domain things and then see. And we did something similar for green jobs. Okay, same thing. Here, they don't even show up. But then it became a business priority and said, cool, we need green things, resample, and rank them. Okay, but if it's only one, it's never going to show up until someone comes and says, we have to include this one. Yes, sir.
Earlier, I think you said a triple store is not enough.
Yeah.
Curious why that is. Like, what
You
do you
want
need that a triple store?
you want some metadata on the triples? On the
Maybe
triples?
just reifying, just keep reifying.
Okay. How practical is that? So you could store it as, I'm not sure. So this is a programming issue. When we implement it, is it still practical to have a reified triple and then create that as part of a triple and then do that for each metadata field that you have and need?
So it comes down to like tooling on how to manage the complexity of that?
That's right. Okay. And that's going to vary too with the size and the scope and how many metadata fields you have for each triple and that sort of thing. Okay. We did our best to avoid that.
What's the alternative? So if you're not using a triple store,
You start from the assumption that you have tuples. Okay, and it can have n fields, however many you only have 3, cool, not a problem. But if you have 15, then you have the infrastructure is already set up for that. Cool, thanks. Yeah, anything. Yes, sir.
What industries do you think are furthest along in using hypergraphs, and are there any notable?
Hypergraphs.
Yeah.
Manufacturing.
Manufacturing. Okay.
Yeah, all
Are
the
there any
all the conversations about digital twins, in essence, are hypergraph representations. Okay, because there are multiple variables, not just 2.
Anything else? Any other industries?
So, what's that?
Finance, I mean,
You're gonna tell me
fin
something?
crime, there's definitely really good cases. of fin crime.
Yes, tell us.
Like you might have a recursive definition for beneficial owner, and the laws are really strange. Like to be able to resolve that, something you're not going to do.
There you go. When in doubt, talk to Paco. Cool.
Thank you very much, Mike.
Appreciate it.
We appreciate it.